Hello test takers, welcome back to Exam Prep Solutions, and in this video we're going to go over how to find the effective stress of the given figure seen below. If you want a method on how to solve any FE exam problem, just download our guide, How to Solve Any FE Exam Problem in 5 Steps. It's a great guide. It shows you an exact step-by-step process so that you're not left guessing or without a method to solve these difficult FE exam problems. So click the link below, download that guide. It's 100% free. But let's get into the problem here. We have a geotechnical engineering problem. Find the effective stress of point A below. So here's point A. We need to find the effective stress at that point. We've got two different soil layers here. One with 105 pounds per cubic foot unit weight, and another one with 130 pounds per cubic foot of unit weight. Now, if you look at our FE exam manual on the right, that's the first thing you're going to want to do is look up the equations that you're going to need in the FE exam manual here. And the equation it gives us here for effective stress is right here. Effective stress equals stress minus U, which is going to be the uplift stress, which is calculated from uplift or pressure head, and U is calculated this way: the uplift or pressure head times the unit weight of water. So it's important in this problem that we're not just going to have to add up or multiply and then sum the height of this soil layer, times it by that, and then the height of this soil layer, add it to and times it by that. That's not going to be the entire problem because we have the water table here. It's located 20 feet down. So we also have to factor in that uplift pressure here. So how are we going to solve this problem? Let's take the first soil layer here, soil layer 1. We go 20 feet times 105 pounds per cubic foot. And then we're going to add to that the next soil layer, 25 feet times 130, because this is the depth, 20 and then 25 all the way to point A. It's not in the center here, it's all the way at the bottom. But we're also going to have to subtract the water portion, the uplift pressure of it. So we're going to take that same 25 feet, we're going to multiply it by the unit weight of water, and we're in standard units here, so we'll go 62.4. And so that is the equation that we're going to have to solve this problem. Now you can write it out so that it's 25 times 130 minus 62.4. I just decided to write out every step so you can see clearly what we're trying to solve for. And once you calculate that all out here, so we get 20 times 105. We use our calculators. 20 times 105 equals 2100. Plus 25 times 130 equals 3250. And then the final part of this equation, we're going to subtract 25 times 62.4 because that is uplifting at point A. 1560 here. And then if we finally total that all up here, 2100 plus 3250 minus 1560, we're going to get a final result of 3790. And so if we look at the answers over here, we're going to select answer B. That's the closest one to this result right here. So what was the process? Find what is the height of the first soil layer, times it by the unit weight, the height of the second soil layer, times it by the unit weight, and then subtract from where that water table is located. So if the water table was located here, probably would have been half the height, but it was located here. So we took 25, multiply it by the unit weight of water, and that's how we find the effective stress at point A. We got answer B for this problem. Like I said, download that free guide, How to Solve Any FE Exam Problem in 5 Steps, and we'll see you guys in the next problem.